So this is another Reigate College Maths Pure 6 video covering finding areas by integration. So you should remember that integration is really two things. It's the reverse of differentiation, and often we're interested in integration without limits there, indefinite integration, but it's also a way of finding areas. We normally think of them as areas underneath the curve, but then we've got to be very careful if our curve goes below the x-axis because the integral comes out negative. There's nothing really very new in this section on finding areas by integration, except that we've now got a lot more ways of integrating that we can use, and finding area works the same for those as well. So let's have a look at the examples in the course workbook. The first one says find the size of the region bound by the curve y equals x sine x, the x-axis, and the lines x equals 0 and x equals pi over 2. So let's just think about this curve first of all, between x equals 0 and x equals pi over 2. In that range, sine of x goes from 0 up to 1, and x obviously goes from 0 up to pi over 2. So without worrying too much about the shape of the curve, we can draw it something like this. We know it's going to be 0 here. We know that at pi over 2 it's going to be pi over 2 times 1, so it's going to have a value of pi over 2. This is pi over 2 here. So it's going to go up something like that. I don't know exactly what shape it is, but it doesn't really matter because we know that it's going to be above the x-axis for that whole section. So we're trying to find this area here. We don't need to worry about it going negative anywhere. So what we're going to do is we're going to say that the area is equal to the integral of x sine x with respect to x from 0 to pi over 2. And you should recognize this as an integral that you're going to integrate by parts. So we're going to say integration by parts. I'm actually not going to go through how we integrate x sine x. We've covered that before, and you should find that you get minus x cos x plus sine x, and then we're going to put the limits in 0 to pi over 2. So now we're going to substitute in, and if I substitute in there, if I substitute pi over 2, I get, well, cos of pi over 2 is 0, so I'm going to get 0 plus sine of pi over 2 we've just seen is 1, 0 plus 1, minus, substituting 0 here, well, this term is going to be 0 if x is 0, and sine of 0 is 0, so this is plus 0, so the whole thing is equal to 1. So this area here is 1 unit squared. Okay, let's have a look at the second question. Get this the right way around. Okay, so we've got two curves here, f of x and g of x. F of x is sine 2x, g of x is sine x cos squared x, and we want the area in between them. So we're going to find the area under f of x by integrating, and the area under g of x by integrating, and we're just going to subtract them. So I'm going to say that the area R is equal to the integral from 0 to pi over 2 of f of x, which is, actually let's write this out, f of x minus integral from 0 to pi over 2 of g of x dx x. So that's equal to the integral of sine 2x minus sine x cos squared x dx from 0 to pi over 2. So this is my f of x, this is my g of x. If I integrate sine of 2x, I get minus a half cos of 2x. And then if I integrate sine of x cos squared of x, I'm going to get cos cubed of x. What am I going to get? I'm going to get a third cos cubed x, and when I differentiate I get 3 times cos squared x times differentiate cos x, I get minus sine x, so I want a plus here. So we can do this all at one go, or you could do these two things completely separately. And it's from 0 to pi over 2. I'm going to substitute in there. So I'm going to substitute in pi over 2. So that's going to be minus a half cos of pi. Cos of pi is minus 1. So this is a half. And then substitute in here, cos of pi over 2 is 0. So that's going to be plus 0. Minus, substitute 0 in here, well cos of 0 is 1, so that's going to be minus a half, and substitute 0 in here, still 1, so plus a third. So that means we've got a half plus a half minus a third, which is 1 minus a third, which is 2 thirds. So the area between these two curves from x equals 0 to pi over 2 is 2/3 of a square unit. That's the end of those examples. There are more practice questions for you to do in the textbook in exercise 11H.